17. The figure below shows a negatively charged rod brought close to, but not touching, an uncharged conductor. Which of the statements below is true regarding what happens to the conductor? A. The conductor is attracted to the rod due to polarization of a charge. Yes, this is the right answer without reading the rest of the answers. Again, a neutral metal ball is suspended by a string. A positively charged insulating rod is placed near the ball, which is observed to be attracted to the rod. This is because the ball becomes positively charged by induction. No. The ball becomes negatively charged by induction. No. The number of electrons in the ball is more than number in the rod. No. So there is a rearrangement of the electrons in the ball. Yes. 19. Which of the following is an example of semiconductor? And of course it's silicon. 20. Materials that have zero resistance to the conduction of electricity are called as superconductors. 21. A spherical conductor is on an insulating stand, as shown in the figure below. A negatively charged rod is brought close to the sphere but doesn't touch the sphere. Which of the following describes the resulting charge on the sphere? Will it become positive? No. Negative? No. No net charge, but the sphere is polarized with positive charge on the left side. Yes, so rearrangement here, the positive come close to the negative rod and negative charge will be repelled. 22. Two initially uncharged conductor 1 and 2 are mounted on insulating stands and are in contact, as shown below. A negatively charged rod is brought near but doesn't touch them. With the rod held in place, conductor 2 is moved to the right by pushing its stand, so that the conductors are separated. Which of the following is now true of the conductor number 2? Will it becomes uncharged? No. Positively charged? No. Negatively charged? Yes, this is the right answer. Because here, again, rearrangement, so this sphere, the positive charge will be attracted here and the negative charge will remain here. 23. The figure below shows a negatively charged rod held close to, but not touching, a pair of conducting spheres 1 and 2, which are in contact with each other. While the rod is still held in place, sphere 2 is moved away from sphere 1. Which of the following statements is true about the charges on the two spheres? As the rod here is negatively charged, so that means that the positive charge will come close to it and the negatively charged will be here. So the right answer would be positive for 1 and negative for 2, so it's B. Two identical sized metal spheres A and B are on oscillating stands, as shown in the diagram below. Sphere A possesses an excess of 6.3 times 10 to the power of 10 electrons and sphere B is neutral. So the question is, which diagram best represents the charge distribution on sphere A? Sphere A becomes negative, so the answer is 3. So it's C. 25. Which diagram best represents the charge distribution on sphere B? As long as A was negatively charged, so the positive charge here will be attracted to the negative charge on A, so the answer would be 4, D. 26. The diagrams below shows two conducting spheres A and B in contact with each other. With a negatively charged object close to them, the spheres are separated. Identify the charges on A and B after separation. Positive, A will be positive and B will be negative because A is close to the negatively charged, so the rearrangement makes A has positive charge and B negative charge, so the answer is A. 27. A positively charged rod is brought close to a charged electroscope. What is the charge on the electroscope? 1. Negative if the leaves fall. That's right. Positive if the leaves move apart. Yes, that's right. Negative if the leaves don't move. That's wrong. So the answer is 1 and 2 only, which is C. Thank you.